All right, everybody go to Twitch, whether you have an account or not, and I want you to put this guy's name in. His name is Rooster PB. Right now he has 12 viewers. Okay, we can all see that he has 12 viewers. I want you to all go and give me a thumbs up when you're at his website. Right? Now we have, what do we got? 3, 6, 9, 12, 15, 17 people, right? Including me now, all right? So he's got 11. He's got 11. Clearly that's me, all right? This is how network address translation works, right? This is it in effect, right? Because NAT gives you an outside facing IP address, and we're all internally on a different network, on the internal network. Are you on there? Are you on there? Give me a thumb. What?
Okay, so this is an excellent start for us to dig more deeply into what network address translation is and how it works. That was an interesting demonstration, but it doesn't get into as much detail as might be helpful. So here I've laid out the network diagram. Lower left we have the school or your home network. On the right we have Twitch or whatever server across the internet we're going to be dealing with. And the professor was trying to get across that from Twitch's point of view, they're only seeing the one public IP address. So when they're doing the user count that they show on the stream, it wouldn't add the, 17 students or whatever to that count. It would count them as one student. So then you have to ask yourself, okay, well, how else might Twitch or some other service distinguish between multiple users that are coming in from one network, because the public IP address isn't the only way. So on the computer that you're on, every single device has its own IP address, and typically you're given a private IP. You can see here I ran a command on my computer to show me my IP address. And this is the 172 range. And so all devices on this local area network in the bottom left will have, a similar address. It'll start with 172, and then the last couple digits will be different, per device. They'll have their own unique IP address. And this IP is the private side. And so Twitch will never see that. What'll happen is this packet is going to traverse from left to right, from our network over to theirs, and then vice versa. They, on their end, have their own private network up there, and they're going to send the packet back our way. What we're going to talk about is what happens in between when these NAT devices, typically it's on the edge router, although it's a separate function from routing, so we're not going to get too much into what's going to go on in the middle here with ISPs and CDNs and reverse proxies and all of that. We're mostly just going to talk about NAT. So what is Twitch's IP address? How do we label that interface? So what I did here is I did a scan of twitch.com, and it comes back and it gives me this IP information. You can see a couple of IPs listed here, but we're going to focus on this 52 IP address that you see there. So we can go ahead and label the outward public IP on their server as that 52 IP address. Now let's go ahead and ask ourselves, what is our public IP? If the 172 is our private IP space, what NAT is doing is it's swapping the public and private IPs. So our public IP in this case is the 146 IP. You can see I curled ipinfo.io. It's a website that just shows you your public IP because we're reaching out to a public server, and so they can see from their end what our public IP is. So let's go ahead and label the diagram thus. So let's zoom into this local area network. We can see a couple of clients here, a couple of students sitting in on that class. Each has their own IP address here. And we have the, private side of our NAT device here, of our router. And then we have the public side. Okay, so when we send a packet to that device, let's understand what NAT is doing under the hood. So basically, it has this table where it does a mapping of private to public IPs. And you can see here, this isn't very useful to do right now. So let's go ahead and add some additional information here. We have some client port information and server port information. And so each client will generate a random client port along with that IP address. The server, HTTP, typically listens on port 443, so that's going to be the same for that server, but each of our clients will pick a random port. And you can see here that, by chance, two clients might pick the same port. And so for this table to be able to uniquely distinguish between those, we might need a little bit additional information. Let's see what that might look like with a packet going from the local area network to the public facing side. So we have the from and the to addresses here that you can see. The 172 with that randomly chosen client port going to the server on port 443. So it's going to hit the NAT functionality, typically within the router. When it goes out the other side, the NAT is going to rewrite that packet. It's going to make a new packet with this new information. It's going to put, hey, I'm coming from this 146 IP. And we see, some trouble here where it's taking the same client port and sending it off to the 52. And you might think, well, that's fine. That packet will make it to the server just fine. But then we ask ourselves, coming back, what does that situation look like? And here's where we need to do a little bit more to distinguish, because when this packet comes back, the server will have flipped it around. So the server made its own packet saying, hey, I'm coming from the 52 address and I'm going back to you at 146 dot whatever. And it's going to use that client port. But remember, we had two internal clients with that same port, different IPs, but that same port. And so this NAT device has no way of distinguishing between those if we were to do it this way. So the fix for this is that we add some additional port information. So this is why it's sometimes called port address translation, because we're also going to swap the ports, or overloaded NAT is another term for this, where we just have the one public IP address, the 146, and then we're going to overload it with multiple clients. And you can see now, if we uniquely, if the NAT table, if the NAT functionality generates a unique port number for each of these connections that it's managing, it will then be able to uniquely identify which client sent that packet, because clients 1 and 3 here now have different ports in the NAT functionality. So it can do a proper lookup to distinguish those packets properly. So we can see the same thing happening. We chose 1001 as the port on this other side here. So 1337 got turned into 1001. So Twitch is going to see this 146 on port 1001. They're not going to see the private IP and port. So here's what it's going to look like if we just abstract away quite a bit of this. So we have our private IP, private port. We know the IP address, we know the port that we're sending it to, so we label our packet that way. It hits the NAT interface, the NAT functionality. Things get swapped at this point in time, and this packet is what goes out onto the internet. Twitch then sees the public IP 146 with the port number that was generated at the NAT router. Twitch, when they respond, they're going to swap their from and to, because it's now coming from the 52 and going back to the 146. That's going to hit our NAT edge device. It's going to get flipped around and then returned to the client. Okay, so another way that Twitch or somebody else would be able to distinguish between multiple devices is by looking deeper into the packet, by looking at other data that comes along with that packet. So, not getting into authenticated users or cookies or anything like that. Let's just talk about one way that, Twitch might be able to use, and that's the user agent header. So the application in your browser, when you're putting this packet together, has this header information. And down at the bottom, you can see that user agent string. And that's unique to each browser version. So this is Mozilla Firefox, but Safari, Chrome, they'll all have their own user agent strings, and every version will have a different string there. Mobile devices, same thing. So Twitch, even though they're seeing that same 146 IP address and different ports, they also are getting this user agent string information. So even if they didn't, rely on just the public IP, they could go deeper and dig into this string. So let's talk about the layers here that I've mentioned a couple of times. So the way this works is we create the packet up on our client on the left-hand side, and it goes up and down this stack. We have layers. You see a couple of missing layers here. We won't get into that too much, but layer 3 is our network layer where we have IP addresses. Our port information is that layer 4 stuff. And then layer 7 is the application data, the HTTP, that raw, header user agent information. And so the browser puts the HTTP together, and then it encases it in the layer 4, and then that goes down the stack to layer 3 and gets encased in another envelope, that big white envelope. And that's what actually gets sent down and then across, and then it goes up the other side. So layer 3 on the other side looks at that outer white envelope, the layer 3 IP information. It unpacks it, goes into the blue envelope, looks at the port information, and then on their end, their servers will unpack it even further and look at the HTTP information, the data, the payload within that packet. And this just goes back and forth, and each layer talks to each layer. So layer 3 talks to layer 3, layer 4 talks to layer 4, layer 7 talks to layer 7. It's all abstracted away, but that's more or less how it works. Thank you so much for your time. Appreciate it. I hope you learned something.